Instruction skill 23 is about understanding angle relationships in a triangle. And before we tackle the problem, let's look at some rules about triangles. The study or the application of triangles is called trigonometry, and these are some of the basic rules of trigonometry. For all triangles, the sum of the measures of all three angles is 180 degrees. So in this triangle, angle A plus angle B plus angle C equal 180. An isosceles triangle has two equal sides and two equal angles. And to find the measure of angle B, you would take 180 minus 2 times the angle A. And just a little bit of vocabulary here. This is called the vertex angle. And these congruent or equal angles are called base angles. And just as a way of example, if your base angles are 70 and 70, the vertex angle would have to be 40, because what this is saying, 180 minus 2 times 70, so 180 minus 140 is that missing vertex angle. So that is an isosceles triangle. Just by way of information, this first triangle is called a scalene triangle because none of its sides or angles are equal. And I know that because we have different letters here. We have A, B, and C. In this one, we have A, and B. That tells me that the two A angles are equal. Then the third type of triangle is called an equilateral triangle. And you notice that this one has an A in each angle. That means that all of the angles are the same. And if the whole triangle is 180, then that means each of these angles would be 60 degrees, because that is how we would get 180 with three of them. So knowing those different types of triangles can be very helpful to you. Let's look at the word problem. And I would be allowed to use a calculator here. Mary is building a backyard storage shed. The dimensions of the roof are shown. Mary will cut a facing piece of plywood to fit the roof line. What is the measure of the roof angle, indicated in the drawing by a question mark, that Mary should cut? All right, if I get a problem like this, the first thing I'm going to do is go to my scrap paper. And I'm going to show you how I would trace this outline. So I'm on my scrap paper. I'm going to draw a similar figure. And then I'm going to use that similar figure on my scrap paper to do my thinking. Okay? Because you can't write in the test booklet. So this is 40. And this is 40. That tells me if those two angles are equal, this is an isosceles triangle. And we are looking for the vertex angle. And the way that I would find that would be to take the 180 for all triangles minus 2 of my 40 degree angles. So 2 times 40 is 80. And 180 minus 80 is 100 degrees in that vertex angle. So I could erase the question mark and put 100 degrees up there for my vertex angle. and that is the answer they have chosen. Sometimes you will see this written this way, and this is actually the way I learned to do it. It's the same math, it just looks a little different. I was taught to make parentheses and put the two angles I know in the parentheses. So the 40s go in there. That's this one and its match over there. And then I would be able to do the parentheses first. 40 and 40 make 80. Then I would subtract from there. But because of order of operations over here, you multiply first. So either way will get you to the answer, and it will work every time. More information is given in this problem than you actually need. We don't need to know the 8 feet. We are interested in the angles, not in the actual lengths. The important point to remember about angles in a triangle is that the sum of the measures of the 3 angles in the triangle is always equal to 180. So approach number 1, you can add the measures of the 2 known angles to get 80 and then subtract that from 180. And that's what I did with this red method. Let me see if I can make a copy of that. So that's what they're describing in this method. Works every time. That's my preferred method. Approach 2 is to subtract each of the known angles from 180. So you would start with 180 and then you would minus 40 and you would minus 40 again. That will get you to 100 because the order of operations says to work from left to right when you have all the same operation. You can also use your calculator. I won't say I would caution. I do not use the calculator because I can do the math more easily in my head. I tend to make mistakes typing on the calculator, so I write it out like this. That's been the habit of a lifetime. It works every time. But you may certainly use the calculator if you feel comfortable doing that. All right, let's practice. Page 59 in your textbook. Concept, which is the best estimate of the measure of angle A. So when I look at angle A, I can tell you that it is tiny. That is a very small, narrow angle. It is definitely a cute little angle. So I would know that it would have to be 1 or 2 because 90 degrees is right here. Let me put the 90-degree line in for you. It's angle A I'm looking at. So here would be 90 degrees. All right, if that is 90, we're talking about just a little tiny sliver. So it is well below 90. It's going to be number 1. A tiny, cute little angle. Number 2, Kareem is making braces to support the shelves he is building in his garage. One of the braces is shown. Which expression tells how to find the measure of angle A? So we are looking for this angle. It's a cute little angle, but it's not tiny. I know that this one is 90 degrees. It's that perfect corner. And they tell me that this one, I like to look at it out here because then you can really see that it's a cute little angle, is 20 degrees. So I could say 180 minus 90 and 20. So 90 and 20 is 110. And then 180 minus that would be 70. You could also use that second approach that they showed where you would say 180 minus 90 minus 20, and you work left to right. So 180 minus 90 is 90. That's this part. And then minus 20 is 70. So either way, you're going to get 70 degrees. So let's pick, remember this is a concept, so let's pick our questions. Our setup. Number 1 is out because triangles do not have 360 degrees. Circles and squares do, but not triangles. So this one is not a possibility. Number 2 has the 180, but it only takes one of the angles out. It's missing the 90-degree angle. So this is not the answer. Number 3 does not have the 180, so I can eliminate that one. Be very careful with number 4 because it looks like this. But look at how this one actually works out. This is why you must know the order of operations. So we have 180 minus 70 is 110. And that is not correct. The problem here, if you're going to use parentheses, you must add the two angles that you already know. The answer is number 5. Be very, very careful with that one. Number 4 is not the answer. If you're going to subtract all the way down, you cannot use parentheses because that interrupts the order that you do the math. That's a tricky one. Number 3. One of the quilt pieces Carla is using in her quilt is shown below. Which expression tells how to find the measure in degrees of angle X? So let's study this thing for just a minute. We are looking for this angle right here. I can tell you it's a cute little angle because it's less than 90. But what's important about this one is that all of the sides are equal. So this is 4, this is 4, and this is 4. This is an equilateral triangle. And it also tells me that if the sides are equal, the angles are equal. So once I find X, I also know this one and I know this one. Okay. I know that there are 180 degrees in a triangle, and I have 3 angles here. So that means that each one of these is 60 degrees. If you know that you have an equilateral triangle, each angle is going to be 60. That will never change. And I know that it's equilateral because the sides, the 4 inches, are the same. So 180 divided by 3 is what I'm looking for, and that is this one. Again, you could eliminate 1 and 2 because they don't have the 180. So if you had to take a guess, you would be able to do that. Number 5 means that you have 180 degrees and you have 4 angles, which is not true. You only have 3 angles. All right, number 4. Finally, we get to do a procedure question. Problems 4 and 5 refer to the diagram below. So I have this large triangle, that is triangle ABC. So we have that large one. And then inside that large one, I have a smaller one here. Now be careful, this is not mama and baby. This is a triangle here. And then I also have the one on the other side, the ABD triangle. So we have 3 triangles in this picture. just depending on which one you want to look at. And they do tell me that this is 90 degrees right there. So I'm going to go ahead and write that in. And actually, before I even do that, let's go ahead and figure out this angle. Because I could take 180 minus 90 and 50. And remember, if I'm using parentheses, I have to add there. So 180 minus 140 gives me 40 degrees for this little piece right there. Okay. I could also tell you that this side would have to be 90 because those two make a straight angle. So we could tell that that's 90. I don't know this one, and I don't know this one. But the others I can figure out. This one's tricky right here because we know part of it. We just don't know all of it. All right, now let's look at our question. What is the measure of angle DBC? Delta Bravo Charlie. And Bravo's in the middle, so that's the angle we're looking for. So let's zoom in here and take a look at angle B. I know part of it, but I don't know the rest of it. If I knew A, I could figure it out, but I don't know A. Here's the problem. We have a question mark here and here, and you can only have one. So I'm hoping not enough information is, and it is not. So what have I done wrong? Oh, I'm sorry. Yes. D, excuse me. That was a stupid mistake. Delta, Bravo, Charlie. So we're going from Delta to Bravo and from Bravo to Charlie. And then that's the rest of the triangle. So we actually have already found this one. We are looking for that 40 degrees. The answer here is 40. I was thinking because of that letter B that I don't know the whole angle, it could be not enough information. So I jumped the gun. I thought I knew, and I didn't. Don't make that mistake. I'm bad to do that. Number 5. What is the measure of angle BAC? So in this one, I am doing Bravo to Alpha. Here we go. Alpha to Charlie. And then the rest of this triangle is connected right here. So now we are looking for this whole angle. And this is where I don't know because I have 2 question marks. I cannot figure it out. So this is where it would be not enough information. Usually when you have that little sliver that you don't know, it sometimes is going to be not enough information. I've seen enough of those type of questions to just look for them. But it was not the case in number 4. Application. A surveyor is plotting the position of a triangular piece of property between several homes. So far, he has made the measurements shown in the diagram. What is the measurement of angle BAC? I'm going to take a picture of this one because I want to make it bigger on another piece of paper. So let me add in, we're going to draw some bow ties on this one. Bow ties are one of my favorite things to do. I just really enjoy those for some reason. So let's put in a sheet of paper, put this picture down, and I'm going to enlarge it as much as I can actually so that I can really get in here and draw what I need to draw. So we are looking at this triangular piece of property right in here. This is what the survey is honing in on. And the question says, so far he has made several measurements. What is the measure of angle BAC? Bravo, Alpha, Charlie. Alpha's in the middle, so we are looking for this one right here. We want to know angle, angle BAC. So we are looking for really the angle alpha, the A. But before I get to that, I'm going to come in here and I'm going to try my best to draw some circles that fit what I need here. They're going to be pretty big because I need them to be about like that maybe. I don't want them to be colored. I do want, I don't want that. Here we go. Let's do, and it's putting text in. Okay, I have no idea what's going on here. Bear with me, please. Let me try this. Here we go. Nope. So that is not going to work. Please bear with me. I'm trying to get a circle built in here where we can do some bow ties. And that's not working. Technology's great until it isn't. There we go. That's as close as I can get it, but it'll work. If I could just get this, there we go. That's what I'm trying to do. Let me make a copy. I'm sorry. Okay. So let's do those bow ties that I showed you in our angles lesson. This is a very important concept. So here is part of one bow tie. That is 55 degrees. If I come across the knot and I do this one, that automatically tells me that that one is also 55 degrees. And so then we're left with this part of the bow tie. I want you to think about the actual size of that angle. Would you say that this section that I'm coloring is a cute little angle? It's not. It's an obtuse angle because it's so wide. And it's going to be the same on this side. But my question to you is, how do I find the number of degrees in one of these green areas? Because once I find one of them, I know the other one. They make a bow tie. So how do I find that number? Well, think about this. Think about a yellow and a green. They make half a circle, so that's 180 degrees. So if I take the 180 and I subtract the 55 that I have up there, and you can use your calculator if you need it. I'm going to try to do this in my head. That is going to give you, that's not right, is it? That's what I get for doing it in my head. I cannot do math in my head because I have dyslexia. And in my brain, the numbers just don't line up right. How about this? So that tells me that that green area is 125 degrees. And that will be the same here. And the four of those should add up to 360. And let me just show you how you can check yourself. I don't like that because it keeps going away. Let's add these up and see what we get. So we have a 55 and a 55. Those are my two yellow sectors. And then I have a 125 and a 125. So that's 20, 5 and 5, 10, 12, 13, 14, 15, 16, and 360. That is the full circle. Okay, here's the cool thing. Once you know those, you have this one, we need to know this one, and then we can find this one. So the next place I'm going to go is down to this 95. We can do a bow tie here. That's good practice. So let me do another bow tie. This one will be different, so I'm going to use different colors. Hopefully I can do a better job on drawing this one. Let me get us to the drawing tool, and here we go. I'll do my best. So I'm going to put a circle around this intersection, and then I'm going to start coloring bow ties. Now, if you're on a test, I know you can't have colored pencils, but you can use your pencil and sketch, color one of them and leave the other one white. That'll work. Just think through it, and if you get it without making bow ties, that's fine. So if this is 95, where's the other piece of that bow tie? Where's the other 95? It's going to be right in here. So by knowing that one is 95, I have found that this one is 95. And together, those make 190 degrees in my circle. That's another way to think about it. The degrees you have left divided two ways. But this is 95, that one is 95. So then let me get one more color. I'll use orange here. We need to find this measurement. Or we can find the other one. Doesn't matter, because once I know one, I know the other. So how am I going to do that? How would you find that orange sector or this orange sector? So if you look at blue and orange together, you know that those make half a circle. And half of 360 is 180. That's also that straight angle, that straight line. So I'm going to take 180 minus 95. And that, I believe, will be 85. So this is 85 degrees, and this is 85 degrees. That makes full circle, 95 and 95, that's 190. And then 85 and 85 is, I'm sorry, what did I just say? 95 and 95 are not 190. Yes, it is. I'm sorry. It's 360 I'm building up to. Then 85 and 85. It's been a long day, guys. Sorry. That's 170. And you put those two together to get the 360. I'm not doing a very good job on this one, am I? So 360, that's full circle. That tells me that my math is right. So now we have one more step to do. If I had this one on a test and I was short on time, I'd make a guess. I know that this is a cute little angle right here. And we could do another bow tie down here, but I won't, because you're probably sick of this. But how am I going to get this angle? Well, I know 55, and I know 85, and I know this is a triangle. So I'm going to say the 180 degrees in the triangle minus the 55 and the 85. So 180 minus the sum of those two, that is going to be 140. That leaves me with 40 degrees for angle A. I could tell you that this is 40 degrees. That's the other half of the bow tie. I can't resist, guys. I'm sorry. This is 40 and that's 40. So what would that other piece be? Let me get a color that we haven't used. We'll use purple. What is this section going to be? It joins a 40 to make a 180. So this is a 140. And this is a 140 as well. So by knowing the rules about bow ties and the rules about triangles, you can do these problems. They do take a lot of thought. You have to be careful. The math is pretty basic, but you see me still missing it. Don't get tripped up in the math like I do. Answer to this question. What is the measure of angle BAC? So B to A to C, that's right here, and that is 40 degrees. That's a good question. But on a test, if you're running low on time, just make a guess and keep going. You know that it's a cute little angle, but all of your choices are acute angles. So that really wouldn't help me. But you can kind of eyeball it and know that it's not a tiny angle. It's not a huge angle. It's somewhere in the middle. So if you're short on time, don't get bogged down in all this. Just make your guess and keep on going. I will say, though, that this is a good thinking exercise. It's good to test your ability to apply these skills.